Okay, so I'm going to make a video summarizing two topics under, or rather one topic under two different lesson numbers. So this is a review of lesson 34 and 35. Lesson 34 starts with solving rational word problems. Rational word problems tend to do with rates. So I'll show you the notes at the top of the page in case you were missing that and wanted to copy that. Oh, it's from 3. Okay. Okay. So, in order to solve a word problem in mathematics, the first thing that I like to do is I like to do what I call creating a word equation. So I want to create a sentence basically that involves the forces or the motions or whatever is involved in the question, and I want to do that in words before I change it into math so that I can be sure that I really understand the situation. Another thing is that word problems that result in rational equations usually have to deal with rates or ratios. And what that looks like is blank per blank. So like miles per hour or like gallons per minute. Those are all rates. The question that I'm going to do as an example on this is going to be question number 11. I figured number 11 was a little complex, so I would handle that. If one inlet pipe can fill the pool in 2 hours with the outlet drain closed, and the same inlet pipe can fill the pool in 2.5 hours with the drain open, how long does it take the drain to empty the pool if there is no water entering the pool? So sort of a lot of things going on here, right? But let me see if I can break this down. I have one inlet pipe, so that's a pipe that's filling water in. And I also have this drain. So I have an outlet drain. It can be open or it can be closed. So I think the inlet pipe puts water in, the drain takes water out, and I want to know how long does it take the drain to empty the pool if there's no water entering. So let me summarize this as a concept first. What I think we have going on for this question is I have the inlet pipe, and that has a fill rate. So the word inlet is totally optional here. So this is the pipe fill rate. Subtract the drain rate, because this right here is water in minus water out. And that'll equal the total rate. So the pipe fill rate, let's handle that. The pipe by itself, okay, so here, look. If one inlet pipe can fill the pool in 2 hours with the outlet drain closed, so the drain is closed, the drain is not doing anything, so the one pipe can fill the pool in 2 hours. So here's the rate. What can it do in 2 hours? It can do one pool over 2 hours minus the drain rate. Do we know how fast the drain can drain the pool? One inlet pipe can drain the pool, fill the pool in 2 hours. The outlet drain closed. Same inlet pipe can fill the pool in 2.5 hours with the drain open. So that's with the pipe and the drain. So it's 2.5 hours. So with the pipe and the drain, which is the total rate, it can do one pool over 2.5 hours. So what I need is they're asking me how long would it take the drain to empty the pool. So that's what I need to find. It can do one pool in how many hours? X hours. So that'll be my variable. You're always going to put time on the bottom. Just a good habit. So now what I need is I need to be able to create a common denominator. Now some of you may decide that instead of 2 hours, you want to write 120 minutes. There's nothing wrong with that. I'm going to leave it the same for now. I'm going to leave it as 2 hours. what I need is I need a common denominator. So let's think about this. I'll do a little scratch work. The multiples of 2 are 2, 4, 6, 8, 10, 12, etc. The multiples of 2.5 are 2.5. Multiply that by 2 is 5. Add another is 7.5. Add another, that's 10. Okay, cool. So I can turn both of these into 10s. So what I'm going to do is I'm going to make the common denominator, multiply by 5 here, and 5 here, by 4 here, and 4 here. So if I want to rewrite, I'm going to get 5 over 10 minus 1 over x is equal to 4 over 10. Look at where all those numbers came from. The method that I like to use for solving these involves crossing out all the denominators. So what I actually want to do is I actually want to make all these denominators 10x. So I'm going to multiply by x over x over x, and 10 over 10. Now this is 10x, this is 10x, and this is 10x. So I can cross out all those denominators. What I have left is an easy equation, 5x minus 10 times 1 is 10, is equal to 4x. I can subtract 5x from both sides, minus 5x. I get that negative 10 is equal to negative 1x. Divide by negative 1 on both sides. And I get that x is equal to 10 hours. So 10 hours is how long the drain would take to empty the tub by itself. It's a pretty long time. Now, I said tub, actually, it's pool in this context. I was thinking of another question. So, to drain a pool in 10 hours, that's not that surprising. It's a lot of water in a pool. So, what I'm doing here is I'm looking at my answer and I'm rationalizing, does it make sense based on the context of the question? And you should always do that with a word problem. Okay, so here was your example from lesson 34. I'm going to switch to lesson 35 now. If you want, you can pause and try another question on this page. Lesson 35, I'm going to do question 3b. These are going to look a little different, but they're still rates. They're still per blank, like something per something. Matthew has answered 4 out of 10 bonus questions correctly in Algebra 2 this semester. So he's got 40% correct right now. 4 out of 10 is 40%. How many questions will it take for him to have 90% correct answers? So here's what I need to do. I need to start off by understanding the context. In order to figure out percentage, Matthew has 4 correct out of 10 total. Now, if Matt gets another question correct, this goes up because he has 5 correct now. And this goes up as well because he's answered 11 questions. So I want you to think about the pattern anytime you see a question like this where things are changing and you're not sure if you understand how to turn it into a formula. So let's think about the pattern. He had 4 correct out of 10. If he gets another one, he's got 5 out of what? 11. If he gets another, he's got 6 correct out of how many total? 12 total questions. So if you see what's happening is it's going up on top and up on bottom. How many though? Do I need to start with the 4 over 10? Do I need to have him get 3 right on top and 3 right on bottom? So he has 7 out of 13? Or does he need to get like 10 questions correct? So we go from 4 over 10 to adding 10 on top and adding 10 on bottom. The things that we don't know, I'm trying to figure out how many does he need. So anytime we don't know something, we don't want to represent it with a number and guess and check forever. What we want to do is we want to make it an x. So for every one that he gets correct, we can just change the value of x. If he gets 5 correct, x equals 5. If he gets 10 correct, x equals 10. If he gets 100 correct, x equals 100. This gives us an equation. But the thing is that we want this to be equal to 90%. Wait, 90 per cent. And cent is a prefix that means 100. Or suffix. I'm not an English teacher. It means 100. So 90 per 100. So I have an equation that looks like this. 4 plus x over 10 plus x equals 90 over 100. Now you can absolutely go ahead and you can cross multiply right now. But me, I like to make my life simpler. This right here is a fraction that can be simplified. How can I simplify 90 over 100? I can divide both by 10, and this will equal 9 over 10. That's way better, especially if I'm going to be multiplying next. I would rather not have to deal with 90 and 100. 9 and 10 seem like much better numbers. So now I can cross multiply. 10 times 4 plus x equals 9 times 10 plus x. What happens next should be obvious. Distribute the 10, distribute the 9. We get 40 plus 10x equals 90 plus 9x. I can subtract 9x from both sides. I get 40 plus x equals 90. Subtract 40 on both sides. And I get that x equals 50. So he needs 50 questions correct. Questions correct in order to have 90%. And let's think about that. How many did he start with? 4. He had 4 correct over 10 total. Plus 50 questions correct, and that means plus 50 questions total. That equals 54 over 60. 54 over 60 is 90%. If you don't believe me, try this. Divide them both by 6. 54 divided by 6 is 9. 60 divided by 6 is 10. That right there is 90%, 9 out of 10. Okay, so that's how I can make sure that my question and my answer match up, that my answer makes sense, is by plugging it back in and checking it in the original equation that I made. Plug it back into the scenario and see if it works out. If you have any issues on any specific questions, please feel free to contact me, shoot me a text or an email, and I will see you in class tomorrow.